All right, I'm back from 5 to 9. I'm going to finish this today. I'm going to finish number 1 and then the other homework tomorrow. And I'm going to send all of those like solutions here in the video form. Okay. So let's start solving from number 5 because we want to do what's easy first, right? No, number 6. Did I say number 5? All right, here we go. Where is it? All right. Um, okay, hold on. Okay, here we are. Right, number 6, it says events A and B are independent, right? And then P A intersection B is PA times PB. Show that PA union B is PA plus PB and minus PA times PB and 1 minus, and then we need to show that these two are exactly equal, right? Then first of all, this part here that I'm going to mark in red, this is trivial. I mean, this directly follows from the axioms of probability, right? And I do not need to really mention that. But going from here to here, the green part is the hard part, right? Going from here to here. So the red part, I can say it follows from the axioms of probability, so I can say this is trivial. Okay. And now for the green part, we need to actually prove that, right? But do you remember that I talked about wishful thinking? When we want to prove an equality or something, right? We want to think that they're exactly the same and then see what needs to happen for them to be exactly equal, right? Then, okay, let's just suppose, claim, what we want to prove is this. PA, PB, minus PA times PB is equal to 1 minus PA complement and PB complement. So, well, this part is already true, right, by the red part, but we need to go from here to here. Then let's just suppose that this is true. Then what needs to happen is this. By wishful thinking, you do not want to really say wishful thinking, but this is like our term, right? Our term that we want to use between just you and I. And then this is also used by a Harvard professor, Joe Blistein. But well, anyways, let's do this. So we want to prove that this is true. And first of all, what we want to do is that we want to use the axioms of probability. Then we know that PA complement is 1 minus PA, right? And then PB complement is 1 minus PB. Therefore, 1 minus PA complement and PB complement is exactly equal to 1 minus PA and then 1 minus PB. Do you agree? And then simplifying this, you have 1 minus PA minus PB and then plus PA and PB, right? Then simplifying this one more time, we have PA plus PB minus PA PB. So, well, if you just use the what is this part first, other than doing this part, then we can get from here to here right away. I mean, without um, any trouble, right? But going from actually like just this is enough. Just proving this is enough. But what if this is given as this is if? If this is true, then show that they're equal. Then what we need to do is really simple. By our wishful thinking, as you see, we have like 1. Uh, what I missed, I mean, what I calculated in my head is 1 minus 1 here, as you see here, that I'm going to mark in purple. 1 minus 1. 1 minus 1, as you see, 1 minus 1. So this is just 0. So what this means is if you add to the right hand side plus 1 and minus 1, then you will get the same result, right? Let's just see that then, if that is true. This is, again, done by wishful thinking. So this is the only difference between the left-hand side and the right-hand side. Therefore, we need to add 1 and then subtract 1, right? And then this part, let's just factor this first. PA and PA times PB, you can group them by PA. And then you have this by these two terms. And then you have PB, and then minus 1, and then plus 1 here, right? Then what ends up happening here is PA 1 minus PB, and then here you can say minus and then 1 minus PB. And you see that they're equal, right? I yeah, I factor this with negative 1, right? And then what ends up happening here is you have PA minus 1, group it by 1 minus PB, and then you have plus 1 here. And now as you see, this one, you factor it by negative 1 again, then this whole thing, and then change the order of operation here. Just move 1 to the other side by the commutative law, then 1 plus this part becomes, since you factored it by negative 1, you have minus PA complement and PB complement, right? By the axioms of probability. I'll take a little break here and then come back for, I mean, I'll have to stop the video here. Then I'm going to solve other problems for you in the next video.